In this video, we are going to talk about section 6.1. There's going to be a few videos for this section because it's kind of a long section, but it is simplifying rational expressions. Okay, so you should know what a rational expression is at this point. We've talked about it. We haven't talked about it in this class much, but you've talked about it in your college algebra class. We have talked about it at one point, though. A rational expression, rational means a fraction, so something on top of something else, like an expression on top of like over an expression. So, for example, an example of a rational expression would be like 2x plus 1 over 3x squared plus 7, or 2 over x minus 1. Okay, so the one thing we have talked about with rational expressions is that the domain is restricted. That means that your domain is not all real numbers. It's all real numbers except for something, okay? We've talked about it in here before. The problem here is having an x on the bottom of a fraction, you're not allowed to divide by 0. So, like if I typed in my calculator 2 divided by 0, it would tell me error, can't do it. Okay, so because of that, my domain, I can plug in any number except for the number that gives me 0 in that problem. So your domain, you can write it a couple of different ways. Basically, the way you find the domain is you set the denominator, the bottom, equal to 0 and solve it. And once you get that number, your answer is, you can write it a couple of different ways. You can write it as like all real numbers, and x cannot equal whatever that number is that you solved for. Okay, you could also write it as negative infinity to whatever your number is, union that number to infinity. That's probably what you did in college algebra. You could write it in set builder notation with the like the squiggly brackets, all x such that x is a real number and x does not equal whatever your number is. I don't really care how you write it in here. Just know that your domain is every single number except for that one number you can't have. Okay, so for example, this problem that we had up here, 2 over x minus 1. If I was going to find the domain for that, so your problem would say, find the domain for the function f of x equals 2 over x minus 1. So to do that, I'm going to take my denominator, the x minus 1. I'm going to set it equal to 0 and solve. Well, the way I solve it is I just add 1 to both sides. And so I get x equals positive 1. And my answer, my domain, is every single number in the whole entire world except for 1. Okay, so you could write it as negative infinity to 1, union 1 to infinity. That's one way you create your answer. Or you could say all real numbers. A fast way to say all real numbers is the R. But x cannot equal 1. Either way. Okay. So let's talk about simplifying these rational expressions. So now we know what a rational expression is. We talked about how the domain is restricted, and if you think about it in college algebra, this thing that you just found, that's your vertical asymptote. Okay, so this problem has a vertical asymptote at 1. That's like that imaginary vertical line where your graph can't cross at that point. Okay, so let's talk about how to simplify rational expressions. To talk about this, we are going to relate it to something easier that we kind of know how to do. Okay, so let's take just a plain old regular fraction with no x's in it. So the fraction 15 over 65. If we were in class right now, I'd say, okay, take a second and reduce that fraction. And you would do it on your paper, and then I would say, okay, let's talk about how you did that. And so probably what you would say is, oh, well, I divided the top by 5, I divided the bottom by 5, and I got 3 over 13. And that's my answer. Okay, so that's essentially what we're doing here with x's and stuff, but think about how we divide using x's. That's long division or synthetic division, and that's not fun. Either one of those is not very much fun. So that we don't have to divide, we're going to change the way we do this problem a little bit, okay? So you can do it this way. It's just kind of awful to do it with long division or synthetic division. So instead, we're going to change this problem into a multiplication problem, okay? So I'm going to rewrite 15 as 15 is just 5 times 3. 65 is 5 times 13. And if you'll notice, we have a 5 on top and a 5 on bottom. A 5 on top and a 5 on bottom, those cancel out, those reduce, those divide out, all those terms mean the same exact thing. Basically, 5 divided by 5 is 1. So if you have something that's exactly the same on top with something that's exactly the same on bottom, you can cancel them out. Technically, they're dividing out. And what is left is our answer of 3 over 13. Okay, so that's how we're going to simplify rational expressions. We're going to rewrite it as a multiplication problem and then divide out things that are exactly the same on top and on bottom to get our answer. Okay, so let's start off with some pretty easy problems. Let me just give you some stuff that's already sort of factored. So if the problem was x plus 2 times x plus 2 on top, and on the bottom it was x squared minus 4. Okay, so our first step is we need to factor anything that can be factored here. And then once we have everything factored, once it's written like a multiplication problem, then I can cancel out or divide out things that are exactly the same. So the top is already factored for us. The bottom, though, I need to factor it. If we were in class right now, I'd say, how do you factor this? This is the difference of two squares. So this is the one where you write two sets of parentheses, one's plus, one's minus. And the top is still x plus 2 times x plus 2. Okay, so now do I have something that's exactly the same on top and on bottom? Yes, this x plus 2 and x plus 2 are exactly the same. So I can cancel those out or divide those out, and I'm left with x plus 2 divided by x minus 2. And that's your answer. Okay, at this point, some people like to get what I like to call cancel happy, and they say, oh, well, I can cancel out these x's now, and I can cancel out these 2's now. You have to think of this, if there's a plus or a minus sign, it's connecting those things. So that x plus 2 is like one thing total. It goes all together. This x minus 2 is one thing total. It goes all together. So since those aren't exactly the same with the signs, I can't cancel those out. Okay, so this is my answer, x plus 2, x minus 2. Okay, so let's do a few of those. Number 2, if I had the problem 4x squared over 10x to the third minus 2x squared. The top, our first step for all these problems is to factor first. On top, 4x squared, can't factor that. It's just 4x squared. There's nothing you can do there. On bottom, 10x cubed minus 2x squared. The way you factor that is, this is a GCF problem. So I take out what they have in common. They have a 2 and an x in common. 2x squared, actually, because this has 2 x's and that has 3. So I can take out a 2x squared. Left over is 10x cubed divided by 2x squared is 5x. 2x squared divided by 2x squared is 1. Okay, so the stuff that I can cancel out here is going to be this part at the beginning. If you can see it just like that, awesome. You can go ahead and cancel it out like that. But for some people, it's helpful to like break that down. I can break down 4 into like 2 times 2. And x squared, I can break down into like x times x. On bottom, 2x squared, that's just a 2 times x. And this is still 5x minus 1. So if it helps, you can do it like this, and then you can see, oh, this 2 and this 2 cancel out. This x and this x cancels out. This x and this x cancels out. And I'm left with a 2 on top. On bottom, a 5x minus 1. Okay, if you could see it here and think, oh, well, 4 divides by a 2, and you get a 2, and the x squares cancel out, that's fine also. Okay, so let's do some more problems similar to that. If I had the problem, let's see, 8x squared plus x minus 7 over 3x plus 3. For this problem, I have to factor the top, factor the bottom. Factoring the top here is a little bit of work. On the side over here, this is AC method. My A value is 8, B value is 1, C value is negative 7. Unfortunately, since A is 8, I have to do the long AC method. So I do A times C. 8 times negative 7 is negative 56. Things that multiply get negative 56 and add to get 1 is 8 and 7. And to get positive 1, it needs to be negative 7, positive 8. So these aren't my answers because A isn't 1. I have to go ahead and work it all out. So 8x squared plus 8x minus 7x minus 7. I'm going to factor this by grouping now. So 2 sets of parentheses. Here, 8x squared plus 8x. It has an 8x in common. Left over is x plus 1. Negative 7x minus 7. You can take out a negative 7. Left over is x plus 1. I think I said minus 1 there. It's supposed to be plus, sorry. And then you can pull out the x plus 1. And left over is 8x minus 7. So that's how the top factors. So let me rewrite this as x plus 1 times 8x minus 7. On bottom, 3x plus 3. It has a greatest common factor of a 3. When you take out the 3, left over is x plus 1. And now, what do you see that's exactly the same on top and bottom? I have this x plus 1 term that I can cancel out. And so I'm left with the answer of 8x minus 7 over 3. And that's your answer. Okay. So that's essentially the biggest idea for today. Basically, we're going to add a couple things onto this, but this is the general idea of today is factor, cancel out, or divide out common factors. You get your answer. Let me show you, there's a couple of problems that have a little trick to them every once in a while, so let me show you that. If I had x plus 2 on top and 2 plus x on bottom, can I cancel those two things out? Are they exactly the same or are they different? So think about that to yourself for a second. So the answer is kind of yes for both of those. Do they look exactly the same right now? No. Are they actually exactly the same? Yes. The reason why is because for addition, it's commutative, which means you can move it around. Essentially, if I put in a number for x, is 5 plus 2 the same thing as 2 plus 5? Well, yes, you get 7 no matter what. So technically, those are exactly the same. If it helps, excuse me, you could rewrite it. The top is still x plus 2. The bottom, I'm going to write the x part first. That's a positive x because there's a plus sign in front of it. Now I'm going to write the 2. That's a positive 2, so I put a plus 2 there. And x plus 2 over x plus 2, that's exactly the same. It divides out, and when it divides out, you're left with 1, because something divided by itself equals 1. Okay, similarly, if I had the problem x minus 2 over 2 minus x, are those exactly the same? The answer for that is no. I cannot just cancel those out there. And the reason why is because subtraction is not commutative. If I put in a number for x, 5. 5 minus 2 is 3. On bottom, what's 2 minus 5? Negative 3. So they're not exactly the same. I can't just move them around and get the same thing. So the way we do this is a little bit different, or same idea. There's just an extra step on it. So I'm going to rewrite the top, just x minus 2. On the bottom, I'm going to rewrite it, but I'm going to put the x part first. So the x part is negative, so negative x. The 2 is positive, so I just turn these around. I didn't switch places. I didn't put the x here and the 2 here with the minus in the middle. I moved the signs with it. Okay, so now you'll see these are exactly opposite. This is a positive x, that's a negative x. This is a negative 2, that's a positive 2. If you think back to when we were factoring by grouping using the AC method, if we had things that the signs were off, the way we fixed that was to factor out a negative 1 from one of them. Okay, so on the bottom, since this first thing is negative, let me take out a negative 1. So negative x divided by negative 1 would just be x. Positive 2 divided by negative 1 would be -2. And notice now these are exactly the same. And my answer here isn't just 1, it is -1 is the answer. Okay, so if you have two things that are backwards, plus sign in the middle, they cancel out. Two things that are backwards with a minus sign in the middle, you have to take out the -1 and then they're the same thing. Okay, so let's look at a problem that has one of those in that. So this would be number 6. If I had the problem x squared minus 9 over, sorry, let me rewrite that. If I had 9 minus x squared over x squared minus 2x minus 3. Okay, so I need to factor this. So on top, 9 minus x squared, I need to factor that. That is the difference of two squares. So it's two sets of parentheses. One's plus, one's minus. Take the square root of each piece. The square root of 9 is 3. That goes at the beginning of both parentheses. The square root of x squared is x. That goes at the end of both parentheses. On bottom, x squared minus 2x minus 3, that is the AC method. So A value is 1, B value is -2, C value is -3. A times C, thankfully A is 1, so this is a shortcut problem. So A times C is 1 times -3, which is -3. Two things multiplied at -3, add to get -2 would be 3 and 1. The 3 needs to be negative. So those are my factors. X minus 3, x plus 1. Okay, so if you notice, I almost have the same thing here. 3 minus x and x minus 3 is almost the same. It's not the same yet, but it's almost the same. The way I can make it the same is I can factor out a -1 on the top. So when I factor out the -1, I'm just going to rewrite this 3 plus x. Here, this would now be x minus 3. On bottom, it's still x minus 3, x plus 1. And now I can cancel those two out or divide them out, and I'm left with -1 times 3 plus x, or x plus 3, however you want to write it, it doesn't matter, over x plus 1. And that is my answer. Okay, so that's how you simplify rational expressions. The next video we'll be talking about how to multiply and divide them, which is essentially the same thing. I hope you understand this video before you move on to the next video, and if you have any questions, please feel free to email me and ask them.